So, Microsoft just released something that I think is way bigger than it sounds at first. It's called OptiMind. Now, if you hear that name and you're thinking, okay, cool, another AI model to write poems or summarize emails, you're actually missing the lead. This one is fundamentally different because it isn't trying to be a general purpose chatbot. Instead, it's laser focused on solving a specific problem that has been a massive bottleneck in the real world for decades: the gap between business intent and mathematical optimization. Think about how huge corporations actually make decisions. Whether it's a shipping giant deciding how to route 10,000 trucks, or a factory figuring out a production schedule for 50 different products with limited labor, the brain behind those choices usually isn't an AI in the way we think of it. It's math. Specifically, it's something called an optimization solver like Gurobi. These solvers are incredibly fast and accurate, but they have one glaring problem. They don't speak human. To use them, you traditionally need an expert, someone with a PhD or a specialized engineering degree, to take a messy sentence like, "We need to maximize profit while making sure factory A doesn't run overtime and shipping route B stays under budget," and translate that into a mixed integer linear program, MILP. This translation process is brutal. It can take days, and if you miss one tiny constraint, the whole model breaks. Microsoft looked at this manual, expert-heavy process and asked, why haven't we automated this yet? That's exactly what OptiMind is designed to do. At its core, OptiMind SFT is a 20 billion parameter model, but it's built with a mixture of experts, MOE architecture. This is a clever design where the model only activates about 3.6 billion parameters for any given task. This gives you the brain power of a massive model with the speed and cost of a much smaller one. Plus, it has a 128,000 token context window. That's a huge deal because real-world business problems aren't just one paragraph. They're often massive documents full of edge cases, deadlines, and resource limits. OptiMind can hold that entire messy reality in its memory at once. But the real secret sauce isn't just the size, it's how they trained it. Microsoft research identified 53 specific classes of optimization problems, from set cover to the traveling salesman problem. They realized that current AI models often fail because the datasets they learn from are noisy or flat out wrong. So they brought in actual human optimization experts to find recurring mistakes the AI was making. These experts wrote specific hint pairs, essentially cheat sheets that tell the model, when you see a problem like this, don't forget this specific mathematical constraint. At its core, OptiMind SFT is a 20 billion parameter model using a mixture of experts, EMOE architecture. This clever design activates only about 3.6 billion parameters per task, offering massive model brainpower with the speed and cost of a much smaller one. Crucially, it boasts a 128,000 token context window, allowing it to process massive, messy, real-world business problems, complete with all their edge cases and resource limits in memory simultaneously. The secret to its success lies in its training. Microsoft research identified 53 specific optimization problem classes. Recognizing that AI models often fail due to noisy datasets, they brought in human optimization experts. These experts helped refine the model by creating hint pairs, essentially guiding the AI on specific mathematical constraints for certain problem types. While the high-level concept is impressive, the way OptiMind operates under the hood is what truly separates it from a standard LLM. When you feed a problem to this model, it doesn't just guess a response based on patterns. It follows a rigorous, multi-stage agentic workflow designed to ensure mathematical accuracy. The process starts with a classification. Before writing a single line of code, the model analyzes your prompt to determine which of the 53 optimization seed classes it belongs to, whether it's a knapsack problem, facility location, or job shop scheduling. Once it identifies the class, it performs prompt augmentation. It essentially gives itself a cheat sheet by pulling in the expert-written hints and error prevention tips specific to that category. This ensures that the model is aware of common pitfalls like forgetting a non-negativity constraint or misconfiguring binary variables before it even starts the formulation. Next, it generates a reasoning trace. It talks through the logic of the problem in plain English, defining the decision variables, the objective function, what we want to maximize or minimize, and the constraints, the rules we have to follow. Only after this logical mapping does it output the final GurobiPy code. Solver in the loop and self-correction. Perhaps the most human-like feature of OptiMind is its ability to learn from its own mistakes in real time. This is called multi-turn correction. If the generated code is executed and the Gurobi solver returns an error, or worse, says the problem is infeasible, meaning the math is impossible to solve, the model doesn't just give up. It captures the specific error logs from the solver, feeds them back into its own context, and analyzes where the logic failed. It then revises the formulation and generates a new corrected script. Reports suggest that this solver-in-the-loop approach significantly reduces the failure rate. Instead of a one-and-done generation, you're getting a model that iterates until the math is sound. For businesses, this means the difference between a broken script and a working schedule. 4. Hardware, requirements, and getting started. Because OptiMind is a 20B parameter model with a massive 128K context window, you can't exactly run it on a standard consumer laptop. To get the best performance, Microsoft recommends a GPU with at least 32GB of VRAM. This typically means using an NVIDIA A100, H100, or the newer B200. For the software side, Microsoft has optimized the model to work with the SGLang ecosystem. The beauty here is that it supports an OpenAI-compatible API. This means if you already have code that talks to GPT-4, you can point it at your local OptiMind server with very minimal changes. You'll also need a valid Gurobi license to execute the generated code, as the model is specifically tuned to work with that solver's syntax. The impact: democratizing decision intelligence. The release of OptiMind marks a shift in the AI landscape. We are moving away from general AI that knows a little bit about everything, and towards specialized AI that is an absolute master of one craft. By releasing this under an MIT license, Microsoft is essentially giving away a high-end tool that used to cost companies thousands of dollars in consulting fees. Rumors suggest that we might see more of these expert models from Microsoft in the future. AI specifically tuned for legal drafting, structural engineering, or advanced chemistry. But for now, OptiMind is the gold standard for anyone trying to turn messy real-world logistics into optimized, cost-saving decisions. It's not just a chatbot, it's an engine for efficiency.